Today we're going to be taking a look at the Sovol SV06 ACE, and this is Sovol's latest take on the original SV06, but with a lot of new features and upgrades. So things like the printer now runs Klipper natively and boasts max speeds of up to 600 millimeters per second and has all of the bells and whistles like resonance compensation, automatic bed leveling, as well as a much nicer new touchscreen and much more. And the best part about all of this is that it is only marginally more expensive than the original SV06. So it looks like a fantastic bargain on paper, but how does it fare in reality? Well, we're gonna find out. As always, I'll walk you guys through the unboxing, assembly, and setup of this printer. We'll go through a ton of test prints and we'll find out what this thing is actually capable of. And of course, at the end, I'll let you guys know what I think about the SV06 ACE. And if you guys are looking to pick one of these up, I've got links to the best possible prices in the video description down below, as well as in the comment section. So go check those out. We've got a lot of stuff to get through here, so let's not waste any more time. Let's get started.
We'll begin this experience with the unboxing of the Sovol SV06 ACE. Everything came packaged very neat and organized with an adequate amount of protection. And at first glance, you could see that nothing in the box was damaged upon arrival. So that's a good sign. As you'd expect with your printer, you will receive an instruction manual, and below that, we can start to remove some of the upper layers of the items inside of the package. And this is where you'll find things like the spool holder bracket, as well as the small touchscreen. On the right hand side of the package here, we've got another box, and inside of here are a bunch of the tools and accessories, such as a bed scraper, the USB stick, the power cable, and a small sample of white filament. At the front edge of the box, we've got the power supply, and you'll see here on the side of the power supply is the input voltage selection. So we'll go ahead and change that right away. Better to do it now than forget to do it later. Next, we can remove the top half of the frame. So we've got the two uprights as well as the X-axis gantry. And then below that, you'll find the bottom half of the printer with the print head attached to it with the harness, and that's pretty embedded in that foam. So I'm gonna have to remove that off camera, and you can see all of the parts laid out here on the table. The printer largely comes pre-assembled, so I don't anticipate it's going to take us very long to put this thing together. But of course, I will walk you through that, so let's get to that now. We'll begin by assembling the two halves of the frame together, and inside of your hardware kit, you will find small baggies of hardware that are clearly labeled with the sizes of the hardware as well as the steps corresponding with the steps inside of the written instruction manual. So we'll begin with those M5x50 socket head cap screws. We'll slip the top half of the frame over the bottom half, where you'll find notches in the sides of the extrusion profiles. Those notches will help things get properly aligned. Make sure you've got the front of the gantry facing the front of the base, and the front of the base can be identified by that blue belt tensioning knob. And we'll just attach those M5x50 socket head cap screws, and we'll tighten them down on both sides, and then we can unwrap the control module. And you'll find that on the back left hand side of the frame, there are two shoulder bolts that will line up with keyways or notches in the plastic case of the main board. You can just press that on and then down to lock it in place. And then on the end of the harness coming off of that main board, we can grab the camera module and attach it to the gantry. There are tab and groove-like features on the gantry and on this camera module that will line up with one another, and you can press it and slide it into place. And then off of the camera module, you'll find this 4-pin connector that will attach to a female connector on the gantry. The next hardware bag contains these M3x8 socket heads, and these are going to be used to attach the print head to the carriage on the gantry. The carriage plate has 3 holes, and the back of the print head has 3 corresponding holes that are threaded. So we'll just press that up against the gantry, we'll insert the screws from the back and tighten those down. Drawing our attention back to the bottom right hand side now of the printer, this is where we're going to attach the touchscreen. You'll find a ribbon cable. Make sure it's looped under the extrusion of the printer. On the ribbon cable, there'll be a label and has the word face on it with an arrow, and that's going to face the arrow on the back side of the plastic enclosure of the touchscreen. You can press the connector into place, and then you can slip the touchscreen onto the bracket that is already attached to the side of the frame, and that'll just lock itself into place. And while we're working in this area, we can attach this 3-pin connector, which is for the filament runout detection sensor. Moving to the back of the printer, we can open up the Step 3 hardware bag, which is some M4x20 socket head cap screws, and those are going to attach the power supply to the back right hand side of the printer. There are 2 matching threaded holes on the one side of the power supply, so this is the orientation that you're going to attach it. Those screws go right through the frame and into those threaded holes on the power supply. At the bottom of this module, you'll find a large 3-pin yellow connector, and you can attach that to the corresponding yellow connector coming off of the back right-hand corner of the frame. At the very top of the frame, this is where you'll find 2 threaded holes, and those will line up with the 2 holes in the spool holder bracket. In hardware bag number 4, you'll find 2 M5x10 button head cap screws that will be used to attach the spool bracket to the top of the printer, and then taped to the frame nearby, you'll find the other end of the filament runout detection sensor cable, and you can plug that into the sensor. Now we can attach the spool holder, and the SV06 comes with a spool holder that appears to be mounted on bearings, which is nice, and it's got a twist lock nut on the back, so you can just place the spool holder through the bracket and twist the nut on the back to attach it. Most printers don't come with spool holders mounted on bearings, so that was nice to see, but it does still bug me just a little that the spool is not going to spin on its center axis, and when the printer gets going, it's probably going to wobble around quite a bit. So I'm going to go ahead and replace this thing with one of my threaded spool holders with conical nuts, so that'll grab the center of the spool and it will hold it securely in place. The mounting receptacle on the back of my spool holder is fully compatible with the SV06 injection molded nut, so we'll go ahead and place that through the spool holder bracket, install the nut, twist it in place, and now it's secure. You can find these spool holders on my website embracemaking.com if you're looking to help support this channel. However, I do have something quite a bit better, which I'll show you guys very shortly if you keep watching. I've just never been a big fan of mounting a 1 kilogram weight to the top of these high-speed bed slinger gantry style printers. So be sure to keep watching for my solution. Rounding out the assembly, we have 2 final connectors to plug in, and these will be for the 2 individual Z-axis motors. All of the connectors on this printer that I've showed you are keyed, so do not worry if you're not a very technical person, you will not be able to plug these things in backwards. And finally, before we can turn this printer on for the very first time, there are 2 blocks of foam wedged under the print bed, both at the front and the back. Be sure not to miss the one at the back. This is really easy to miss and it will cause you problems if you do not take it out. Now we're ready to turn the printer on, and as you would imagine, when you turn it on, the screen comes on and you'll be greeted with the Sovol splash screen. You'll then be prompted to start the initial setup where you can select your language and you can connect your printer to your wireless network. You'll definitely want to do this as your printer will be able to receive over-the-air updates. We'll get to that in a moment. Then we can go to the self-check and we can start this process. It's completely hands-off and it will take about 15 minutes to complete. And this is typical of most 3D printers running Klipper these days. However, the one thing that I was most intrigued with was the Z-axis tilt calibration. Most gantry-style bed slinger printers these days have 2 vertical lead screws that are belted together to keep them synchronized. So if the gantry comes tilted from the factory, then you'd have to line that up and square it to the machine frame manually. On the SV06 ACE, they're independent and driven by 2 separate motors, so it looks like the machine is able to calibrate for that tilt automatically. Once all the calibration is complete, on the bottom left-hand corner, there is a button for the settings. You can head into system and you can check for over-the-air updates. In my case, there was already one ready right out of the box, so I'll update to firmware version 16.0. And once that's done, I can click on the controls icon. I can home all the axes, and now I can move the Z-axis up a few times, and we can go over to the filament control. Now click on load filament, and that's going to heat up the hot end to the appropriate temperature for the pre-selected material, which was PLA. I'll route my material through the filament runout detection sensor at the top, paying attention to the directional arrow on that sensor, and then I'll place it inside of the print head. There's a tensioning lever that you can depress and then put the filament inside so that the extruder can grab it, and when you press confirm on the touchscreen, it will begin to prime the nozzle. The next step to getting started is to slice a file in a slicer, and for the SV06 ACE, there's a version of OrcaSlicer located on the USB stick that comes with the printer that has a preset available for the SV06 ACE in the printer selection. I had this printer pre-release, so existing versions of OrcaSlicer at the time did not have the SV06 ACE version in there, but newer versions of OrcaSlicer should have it. In the physical printer properties, I'm going to type in the IP address of the machine, and if you're not aware, you can find that IP address on the touchscreen of the printer itself in the network tab. And then I'm going to load in a small test model to begin with, and this one here is going to be a Battleship Benchy. This model here has some very nice fine details that we'll use to initially test this machine. You'll see around the cannons there are some very steep overhangs as well as small features. And in the print settings, I'm not going to deviate a whole lot from the default settings. The only thing that I've changed really is the infill as well as the infill type to triangles and the wall count to 3. The slice preview looks good. The time to print looks to be about 54 minutes, and although this is a larger model of a benchy, that is very high, and that's likely due to the minimum layer time setting, which we can adjust later. But for now, we'll just run this as is, and I'm going to export the file to the USB stick, plug the USB stick into the top of the printer, then we can select that file and start printing it. Files can also be transferred wirelessly, which we'll also do in a moment, but first in the device tab inside of OrcaSlicer, we're going to want to change the language over to English. That is, unless of course you can read Chinese, which I cannot. So I'll make that change in the general settings, and now it'll be much easier for me, and probably most of you, to navigate the mainsail dashboard and control your printer remotely. Let's now check in on how our first print is going and see if we have to make any adjustments to the first layer. It's looking like the first layer is running a little too close to the print bed, and so in the touchscreen we can tap on the settings icon and we can make adjustments to the Z offset live. I'm going to bump the Z offset up by 0.1 millimeters in this case, and that fixed my first layer. The benchy model has a pretty small first layer, so it's not ideal to do this. If you want to make adjustments live to your first layer while the print is running, you probably want to choose a model with a larger surface area at the first layer. The SV06 will save that Z offset, so not to worry, you won't have to do that again. And the rest of this print turned out looking pretty good. There was some minor stringing that could probably be pretty easily tuned out with just temperature or retraction settings, and this filament's been sitting out for a little while, so perhaps it has a little bit of moisture in it. Otherwise, the SV06 ACE captured all of the very fine details in the print, and all of the overhangs looked very good as well. So this model did a fine enough job serving its purpose as an introductory model. It's just getting started with the SV06 ACE and making sure everything is operating as expected. Let's move on to something a little more interesting now. Next, I've got a multi-part model which we'll assemble at the end, and the first piece in the model is the main body. This part has a lot of interesting features, including a large inner dome, and right now it's not taking up enough of the build area. To make this print a little more impressive, we're going to scale it up 200%. I'm going to leave the outer wall count to 2 walls, and I'm going to change the infill type to triangles, and I'm going to leave the infill density to only 10%. After slicing the model, I noticed that there is a brim enabled, so I'll head into the Others tab, and I'm going to disable the brim, reslice it, and then we can send this off to the SV06 ACE wirelessly. And to do that, we'll just click the print button in the top right hand corner of the screen. I'll leave it with the default naming convention and click upload and print, and this will send it off to the printer and start printing in a single click. Once the print is uploaded, OrcaSlicer will switch over to the device tab automatically. Alternatively, if you already have a G-code file on your computer that you previously sliced and you want to upload directly to the SV06, within the mainsail dashboard, you can head on down to G-code files. You can click the blue upload icon and find that G-code file on your computer and upload it. Additionally, you can click on the add a folder icon. You can create a new directory, and then you can move some of your G-code files into those folders to keep yourself better organized. The only downside to doing this is that any files you place in subdirectories do not seem to be accessible from the touchscreen. So you will be limited to starting those prints from the mainsail dashboard like I'm doing right here. And I've asked Sovol if that's something that they can change in a future firmware release, so we'll see if that happens. For this model, I very carefully watched the first layer go down, and while white filament isn't the greatest to inspect on camera and show you guys, it is very nice on that black PEI print bed to inspect the first layer and make sure that the Z offset is correct and the auto bed leveling is working perfectly. And in this case, it was flawless. As for the rest of the print, it looked very respectable. Now again, I know white is not the best filament color to inspect parts, especially on camera, but I was not seeing any severe layer lines, and I wasn't seeing any Z banding issues. And in areas around the eyes and the mouth, where there would have been some travel moves, I wasn't seeing the severe stringing that I had seen in the first model. The only unsightly part of the model was on the inside, and that's because the inside of this model was hollowed out and it is a dome shape. The top of that dome would have been a complete overhang, and I chose not to support it because it was on the inside and you wouldn't see it, so why waste filament? Next I printed the ghost tail, and the thing that I was most impressed with here was how smooth it looked and felt considering the angle of this top surface. Now normally I would have expected this surface to have a lot of pronounced steps, but even at a pretty standard 0.2mm layer height, I didn't seem to see those or feel them as much. So now let's move away from that white filament, and in the filament tab on the touchscreen, we can just press unload. If you're working with material other than PLA, you would have had to press on the button showing that you're using ABS or another material and set a different load and unload temperature. And since we're on the topic of filament and we're going to be loading in a new color, I'll show you guys my universal spool stand solution that I hinted at earlier in the video. When we were initially assembling the machine, I installed my threaded spool holder into the SV06 spool holder bracket. And at the time, I mentioned that it wasn't crazy about hanging a 1 kilogram spool weight on top of the printer frame. When the printer really gets going, that roll of filament starts to vibrate, and I feel like those vibrations will get transferred down into the frame and potentially shake the gantry and result in print artifacts. To remove that vibrating mass from the frame, instead I've put it on the universal spool stand. And I've named it universal because if you guys have watched a bunch of my other videos, you'll see that I've used it on a wide range of printers at this point. The height can be adjusted to accommodate taller or shorter printers, and the SV06 doesn't require any special brackets or adapters because the filament runout detection sensor is already located at the top of the printer. So it makes this a very simple install. If you're looking for one for your printer, if you got an SV06 or something else, check it out on my website, embracebaking.com, for the full application list. This next print is pretty straightforward, and it's these cone-shaped teeth that I will also scale up 200%, and I'll be printing them in eSun Gray PLA+. I've not made any changes to the material profile in this case, as I like to see how the generic profile performs across a wide variety of brands. It's a smaller part and the print itself wasn't very exciting, so I cut right to the final product, and I thought they came out looking pretty good, especially towards the tips of the teeth, where if the part cooling was insufficient, they'd probably look pretty sloppy. The next piece in this multi-part model is the ghost tongue, and this doubles as the stand for the entire model. So for this, I want a little more strength, so I've increased the number of outer walls to 3. I've also increased the infill to 15%, and I'm going to go into the material settings and increase the nozzle temperature to 230 degrees. I'm still using PLA, but it's eSun Magic Chameleon PLA, and I find that with this stuff here, you do have to print at a higher nozzle temperature to prevent nozzle clogging. This worked out great on the SV06 ACE, and I didn't see any signs of under extrusion or nozzle clogging during the print, and I was very impressed with the final result. The glitter metallic properties of the filament are very attractive, but they do also help hide any sort of print artifacts. So it's kind of hard to see because it's very distracting to the eye, but I do feel like I see some very minor ghosting in this part, but I'd say it's well within an acceptable limit. I switched up the colors yet again to a metallic gold, and in the past with this material, I also experienced some nozzle clogging on occasion, so I played it safe with an elevated nozzle temperature, so I fully expected to see a little bit of stringing in this part. But because of the higher nozzle temperature, the one thing that I was concerned with was the overhangs on the peaks of that crown. And this would have been even more of a challenge than those gray teeth that I showed you guys a moment ago. So I was happy to see the part cooling fan do its job well, and all of these peaks on the crown looked uniform, so the part cooling fan ductwork doesn't seem to be having any issues with it being particularly directional. And after that part, I went with yet again another filament change, this time some Filamentum translucent green PLA. I've had this stuff sitting in my collection of filaments for a very long time, and I find with some of these clear or translucent filaments, they tend to get very brittle over time. Luckily, I didn't experience the filament cracking or breaking mid-print, and this gem looks very nice. I've got no complaints in terms of how the SV06 printed this thing. However, if I were to print it again, I would choose a different infill setting because you can see the infill through the walls of this filament. Now that I've got all the parts printed for this model, we can start to put some of them together and see how the SV06 performs in terms of dimensional accuracy. There were a few parts that I didn't show getting printed for this model, one of them being the male thread that gets attached to the tail, so the tail can get attached to the main body. And that printed just as nicely as the other parts, and you can see that the male and female threads fit together. And the other two small parts that I didn't show were the two purple eyes, as well as the red insert for his mouth. I put a little glue on those just to make sure that they never fall out, but they actually would have fit together inside of that model as a nice press fit. Some components like the crown and jewel were not intended to be press fit and they are intended to be glued, so I glued those down, and I also applied some glue to the tongue despite it being a good press fit too. If you guys are looking for this impressive model, I bought it off of Cult 3D, so I'll put a link to that down in the video description below so you guys can go and support that talented creator. For this next print, we'll switch gears a little bit and we're going to print something with more geometric features as well as with a functional purpose. And this model here is going to require some painted on supports in certain sections, such as these counterboard holes. Once I've painted on the supports, then I can enable the manual supports, and this will be a good test to see if the support material easily comes off the main body of the parts or it sticks too hard, and we'll get to see whether or not the support settings inside of OrcaSlicer are appropriate for the SV06 ACE. And for this print here, I'm going to be using black eSun PLA+. This is my favorite PLA based material for mechanical performance, and the black color makes all of the details very easy to see on camera, so we should have a very good chance at analyzing these parts when they're completed. There are 3 parts on this build, and the first one came out looking very nice. All of these straight walls looked uniform, and there was a small amount of fillet on this one edge where it didn't adhere to the layer below it. This edge had a small fillet on it, and the printer didn't seem to like that too much. It was nice to see no ringing to the left and right of the lettering, although the lettering itself was a bit of a different color, perhaps due to some different part cooling happening in that area. And the support material came off very easily, although the layers above it weren't so clean. I might have to play around a little bit with the density of the support interface layers. On this second part here, you can see a few artifacts that appear to be slight under extrusion, and this harsh light on the black plastic makes any layer variance very obvious depending on the angle at which you hold this part. So some of those lines look a bit exaggerated, but technically they're there. Now the one area that I was rather disappointed with on this particular part were these top sections here with the holes. There was a lot of ghosting and ringing on those holes for some reason, but the top flat surfaces of the part looked exceptional. And on the back side of this part, there's a flat surface with my logo. Again, no ghosting or ringing around the logo itself, unlike those holes. And then moving on to the third part, this one's got a top surface layer with a bit more surface area, and it looks pretty good overall. There were some very minor signs of the nozzle dragging across that surface, but nothing you would really see under normal lighting conditions. The lettering that was printed on the bottom, so on the first layer, that looked crisp and sharp, and the supports also came off quite easily, just like the first part. But also, just like the first part, the layers that were printed on top of those could be a little cleaner, so I'll have to play around a little bit with the support settings. Making our way through some more sample prints, this time I've got another multi-part print, and somewhat similar to the first character that I printed in this video, there is a large interior dome. Now I could print this part upside down on that flat spot on the top of its head, and it'd print somewhat like a bowl, but I would be concerned that the severe overhangs of the bottom of the bowl would not come out looking quite clean enough, and this is the top of the model, so that would be what is visible. So I'm going to print it this way and potentially sacrifice the quality of the inside of this dome. I added some tree supports right in the middle where I thought the part could potentially fail, because in the middle of that dome, that would be a complete overhang. The outer walls turned out looking pretty good. If I were to really nitpick, I would say that there are a few small areas where you do see some minor bumps on that surface, but keep in mind this is a very harsh light, and this isn't really something that you would notice under normal lighting conditions. It was the underside of the dome near the top that was the messiest, and this is where those layers transition into extreme overhangs. The perimeter walls in this section do not have very much surface area to attach to the layer below it, and they'll separate from the model and look very stringy like this, so I will have to do some post-processing and cut those off. The inside of that part will not be visible when the assembly is complete, so that's why I printed it like that. Now the other half of this character's body is the bottom of the sphere, and I am going to print it in this configuration like a bowl with the open side facing up. And although the inside of this bowl will not be visible when the part is assembled, it does have some locking features around the top edge of the bowl that need to be very accurate, so I had to print it in this configuration to avoid using supports in those areas. And so as I explained, with the first half of the sphere that I printed, at the bottom of the bowl shape, there's a very severe overhang where it transitions from the flat surface into the curved surface, and those look a little bit messy. They didn't turn out so great, but in this case it's not such a big deal because they'll be facing down and you likely won't see them. The quality of the walls improves significantly as you move up the model and the overhangs become less severe, and the area that I was most concerned with was this top lip where we have this twist lock feature. And I explained that's why I didn't want to print that part upside down, and those features came out looking very nice, so I have no doubt that the two halves will mate together successfully. Moving on to the second part in this particular build, I printed it in some sparkle gray PLA. And this part here required some support material inside of that hole, and that came off with no issue. And similar to some of the other metallic or sparkle-like filaments that I've shown in this video, they do a good job at hiding small imperfections, although I do think that this particular part here would have looked just fine with a regular filament. But this advantage of using the sparkle filament is true across all printers, not just for the Sovol. So I would highly recommend using it if you're looking to print something where you do need the walls to look very nice. So for these parts here in the sparkle gray, I thought the SV06 ACE knocked these two out of the park. Earlier in the video I printed a rather small part in this metallic gold PLA, and that small part looked pretty good, so I decided to use it again on these larger parts. These are the feet of the character that we're going to be building, and the metallic gold filament looks amazing. All of the surfaces of these 2 feet that I printed came out looking incredible, except for the area at the heel, where again there is a very steep overhang, but otherwise I thought everything on these 2 parts came out beautiful. Other than the first layer and those tiny little square pegs, there are really no straight edges on this part, and even those square pegs are printed on angle if you look at them very closely. The printer was able to very nicely conquer all of those curved surfaces and transitions, and it was just a very overall tidy looking part. I'm going to put all these parts together in an assembly, and I've seen a lot of people online use glues that they claim are specific to 3D printed materials such as PLA, and perhaps there is some validity to that. However, I find that for models like this that just require medium bond strength, hot glue works just fine. And during the assembly of these parts, I didn't find any issues with the tolerances of the parts that were mating together, and the final feature, which is the twist lock feature between the top and bottom halves of this character, worked out just fine as well. If you guys are looking for this model, I'll put a link to it in the video description down below. In models such as the previous one, I had mentioned that parts fit together just fine, but I realized that there's a bit of a problem with that when you're not the designer of those parts, so you're not entirely aware of what kind of clearances were built into them. So I'll print one of these clearance tests, and it still doesn't necessarily mean that the parts themselves will be dimensionally accurate, but without getting too technical, it will still give us a pretty good idea of what the printer is capable of in terms of printing parts that either fit together or perhaps are print-in-place parts, where these kinds of clearances really come into play. And this particular clearance test has these print-in-place hinged fingers, with clearances on the hinges ranging from 0.1 millimeters all the way up to 0.45 millimeters. Personally, I think that if the fingers aren't fused between 0.2 and 0.25 millimeters, that's a very good result, and anything below that is excellent. And in this case, surprisingly, all of the fingers broke free, and I was able to do that right on the print bed. The print bed adhesion from the main body of the part to the bed itself was strong enough that I could break all of the fingers free without applying very much force, and that includes even the smallest clearance at 0.1 millimeters. So I thought that aspect of this printer was very impressive, and that gave me the confidence to move on to another print-in-place part, which has a print-in-place peg and hole, kind of similar to a hinge, and this thing is a print-in-place catapult. It required some organic tree supports that were easily removed, and the walls of this part looked very uniform and smooth overall, and I had no doubt that the arm of the catapult would break free from the rest of the frame. As you could see, there was quite a bit of clearance between the peg and the hole. However, that peg was completely floating in the air, so when I went to slice this part, I did have to add a tiny bit of support between the peg and the hole where the peg would start to get built up. So this did require me to work these 2 parts in a little bit, and that would help remove the support material from between those 2 features. The only thing left to do on this part was add an elastic band and have a little bit of fun. Another popular style of model that I see a lot of people printing these days on social media are these woven style baskets. The challenge with printing these parts is that there are a lot of very fine details and a lot of bridging. And depending on your print speed settings for certain features like bridging, this could result in a very long print. And so in this case, with the default settings, this small basket will take 4.5 hours to print. I'll be using some matte blue PLA from Sunlu, and it actually matches the colors of the frame of the SV06 quite nicely. So if you do end up buying one of these printers and you want to print some accessories for your SV06 ACE, this is a pretty good color match, and I'll put a link to it down in the video description below. Color aside, the printer tackled this part almost flawlessly. The bridging of those woven sections was fairly short, so I really didn't anticipate any issues there, but I was a little concerned with some of the filleted edges, but luckily those came out looking very clean. There was just some very minor stringing on this part, but it was the top twisted sections where you would find some very steep overhangs again, where the print looked a little rough on those undersides. Given the overhang angle, it wasn't too bad, but it's worth pointing out. We'll go ahead and print one more part to round out this video, but as we set up this print, I'm going to show you guys how to use the time-lapse feature of the SV06 ACE because it does come with an onboard camera. The camera is located on the right-hand side of the gantry, so I'm going to rotate this model around 180 degrees, so as the camera shoots the print as it comes up, we should be able to see the inside of this moon model, so it's not blocked by the crescent on the left-hand side. I'm just going to print this part here with 2 walls, a low infill density of 12%, and I'm going to use the triangle infill. There will be some challenging spots for this printer along the bottom of the tea light candle holder as well as the top peak of the crescent moon. I'm going to run this part here without supports, fully expecting that these regions will not come out looking completely clean. When it comes to time-lapse videos, I just find that support material generally takes away from the effect of watching the geometry of the model itself get built up. So I'll slice that model and upload to the printer, and in the device tab of the SV06, one of the things you may have noticed is that the camera view does not appear. And we can fix that by going into the settings, going down to webcam, and click on add webcam. And I'm just going to go with all of the default settings, and I'll just name this camera to SV06 cam. Then we can click on save webcam, and in the dashboard view, the webcam view now appears, so we can remotely monitor our prints. Perhaps this is something you won't have to do in the future if Sovol can change that in the firmware settings. To initiate a time-lapse video, you can simply click on the file you want to print, select print, and then when the start job window comes up, you can toggle the time-lapse feature on and off. In this case, I'll toggle it on, and while I was monitoring this print, the one thing I noticed is that the print head was not getting parked to the end of the gantry upon each layer change, and I'll talk about the pros and cons of that in a moment. But first, we'll give this last part a quick inspection, and you can see around these sharp corners there was a little bit of ringing, and at the top of the crescent peak, as I had stated while we were slicing the model, I had fully expected to see some print artifacts here, as the top peak and the bottom of the candlelight holder are going to be complete overhangs. So those areas didn't surprise me at all, but I would have liked to have seen a little less ringing on the surfaces of that crescent moon. However, under a softer light, they're much less noticeable, and it still looks like a pretty cool model. Now let's head back into the mainsail dashboard and find our time-lapse file, which, as you would expect, you will find under the time-lapse tab. You can click on the file and play it right within mainsail, although this will be streaming directly from your printer, so you may experience some interruptions depending on your Wi-Fi connection. But for a smoother experience, you can download the file by clicking on the download button. Now this doesn't seem to do anything for me, so instead I click on those 3 dots and click on download, and that initiates the download. And the file will end up in your downloads folder of your web browser, and that's because the device tab in OrcaSlicer is effectively a web browser. At this point, you can keep the video file on your device or delete it to save disk space. And this is what this time-lapse video looks like, and I've slowed it down to just be able to point out a few things while it's running. First, as I mentioned earlier, I noticed that the printhead is not parked at the end of the gantry upon each layer change, so you don't get that effect where the printhead is parked in the same spot at each capture and the part magically appears to build itself out of thin air. So that makes the time-lapse video a little less interesting to look at, but the advantage to this is that generally when you do move the nozzle away from the part to take those pictures, you can run into some quality issues. For example, you may get a lot of stringing. So in this case, you sacrifice the cool looking video for a higher quality looking part. And the other thing I'll just point out here is the video quality itself. It's obviously pretty low resolution, and that's par for the course for most 3D printers that I've reviewed. I've owned quite a few printers at this point, and I haven't seen any that come with a camera that is very good quality. So if you're looking to do time-lapse videos to share on social media, I would recommend getting an external camera to do that. And I would say that the onboard cameras in most 3D printers these days are best suited for remote viewing.
So this is actually my first Sovol printer, and in the past I've heard some decent things about some of the printers in their lineup, but honestly I wasn't entirely sure what to expect. Although after testing this thing out, I'm definitely happy that I gave them a chance to send me the SV06 ACE, because overall I've been very happy with it. I received this printer pre-release, so when I got it, there really wasn't a lot of information floating around about it on the internet, And the first thing that I did was head on over to the Sovol website to compare the original SV06 with the product that I received, and a few things stood out to me right away. So first of all, with the frame, I noticed that on the X and Y axes, previously there were linear rods, and there still are linear rods here, but now they're connected with an aluminum extrusion in between those rods, where previously there wasn't that extrusion there, and that really stiffens up the frame. The other thing I noticed was the printhead has a pressure sensor now instead of the previous version, which had a proximity sensor. I also noticed that the SV06 ACE has got a camera. Again, the original SV06 does not. And another big thing was the touchscreen. The ACE version has a much nicer touchscreen than the original SV06. And of course, the addition of Klipper, which enables a lot more advanced features such as the resonance compensation and that Z-axis tilt compensation. Because on this model here, the two Z motors are independent, they're not belted together, so they can actually tilt the gantry and level it out for you, so you don't have to do that manually. Now, my experience with this printer has been almost perfect. I did run into one issue early on when I first got started with this, and it had to do with the part cooling fan. So the SV06 ACE now runs the part cooling fan and the hot end fan with 4-wire fans. So one of those wires is a signal wire that the computer can monitor, and it can keep track of the speed of those fans. And this seems like a good idea for the hot end fan because, you know, keeping that thing running and making sure that it's running could prevent a thermal runaway condition. But on the part cooling fan, this could be a little bit overkill. And the issue that I ran into was that the computer was thinking that the part cooling fan was not running. In fact, it was running, I verified, but I think maybe the computer was trying to pull the fan signal wire too quickly, and it thought that, again, it wasn't running, and then it would kill the print. Now, luckily, I was able to very easily fix this by going into the print configuration file inside of Mainsail and just turning that feature off so it's not going to look for that signal wire anymore on the part cooling fan. And after also upgrading the firmware on this machine twice during my time with this thing, the problem never came back, but it's worth mentioning. It's also worth mentioning that I did bring this up with Sovol, and they responded very quickly and they were very receptive to my feedback, so I thought that was great. And I figured that this is something that they could very easily fix in a firmware update if they haven't done that already. The rest of my experience with the SV06 ACE was very much drama-free. As you guys saw with the parts that I produced, the print quality looked excellent and the details were very sharp. Now, in a perfect world, I would improve two small things. One of them would be the steep to extreme overhangs. Those could potentially be improved maybe with some better part cooling, but at some point when you're printing almost entirely in the air, there's really not a whole lot the printer can do about that. And the second thing would be some of the slight ringing and ghosting that I saw in some features of the parts. It wasn't all of them, which was odd. It was just some of them, and that could have something also to do with the filament color and looking at it under a certain light, but you can definitely see that it's there in some cases. And perhaps that's also something that can be fixed or addressed in future firmware updates. And I also suspect that as time goes on and community profiles become available for the SV06 ACE, you're going to see even more improvement in print quality. One small detail that I noticed and appreciated was the access to the main board. So when I had that fan exception error that I mentioned earlier, I was trying to track that down, and the first thing I was checking was the wired connections from the part cooling fan to the main board. And to access the main board, it's so easy. They've just got one screw that you can loosen off, and the cover on the enclosure swings open. So you don't have to disassemble the whole thing, start to remove a ton of screws. It's an easy access hatch to the main board, so you can check wiring if you ever have to do that. It's just a small thing, but again, it's something that I appreciated as a clever design choice. I also really liked the minimalist screen layout. So on some touchscreens on 3D printers, you get a huge menu with a lot of features and options that are rarely accessed or used, and this can create confusion and clutter. This thing was pretty clean and straightforward. The user interface was nice and simple, and this could be an advantage for beginner users. And finally, one of the best things about this printer is the price. At under $300, it's an insane value for both the hardware and features and performance that you're getting, especially compared to what else is out on the market right now. And for the best possible price, I've got links in the video description down below as well as in the comment section. And if you guys are looking for links to that spool stand that I showed you early in the video, I'll put links in there as well. It fits the SV06 ACE as well as a wide range of other printers, and that is on my website, embracemaking.com. And that brings us to the end of this video. Thank you guys so much for watching right to the end, and thank you to Sovol for sending me the SV06 ACE so I could test it out and of course bring this content to you guys. And if you guys enjoy this thorough content, be sure to like and subscribe. It goes a long way to supporting me and this channel. I would really appreciate that. Thanks for watching and see you guys next time.